Hello and welcome to this low-level JavaScript video where today we're going to be building a command line hex editor. I'll get into what a hex editor is in a second if you don't know what that is, but my motivation for this is that lately, recently in a project that I've been working on, I've wanted the ability to go in and change some stuff in a binary file, right? So go in and modify some exact bytes. I also just want to read through it and see what's in there and kind of maybe compare it to other files. And I've been looking for a kind of off the shelf solution for binary file editing. I work on Linux, but I used to work on Mac, and yeah, I just haven't actually really been able to find a good command line hex editor. And what I found is a lot of people recommending a method which I think is terrible in terms of user experience. And so what I really want is just to build a dedicated tool, and I'm pretty sure I can do it in a nice way, and I'm pretty sure I can. Well, the reason I'm making a video about it is because I'm pretty sure I can show you something cool as well along the way. Okay, so before we get into these goals and everything here from what I'm trying to go for, and I'm just going to pop up this little window here so I can control what's being shown. Yeah, that's good. I want to just kind of show you the methodology I kind of have to use now, or that at least has been recommended to me. So I'm in this directory. I've kind of already set up a little repository. I'm not going to be going into the setup of the repo. I'll show you what library I'm using. There's one library involved, so it's not a deep dependency thing. I guess there's technically two, but you can think of it as being one. I've got a binary file here, right? It's just some randomly generated bytes. But what I'm going to do is I'm going to dump the hex dump of it. So I'm going to use a program called XXD, which is installed by default on Linux and Mac, I believe. And what it does is it just does a hex dump, right? So hex dump of example.bin, and it's going to just throw it out on the screen. And yeah, so this is good for like reviewing what's going on here. Like just to go over the interface of what you see here. Here, this column on the left, this is showing us the offset into the file. So this is like basically the address of each byte that we're looking at. Here in the middle, we see the actual byte representation. I guess they're grouped together in sort of half words in 16-bit groups. But yeah, each collection of two hex characters is a byte. So you can see, this is byte 1 from a 0 index position. This is byte 2, byte 3, and so on, and so you can kind of get a sense of it. And over here, what we've got is an ASCII representation of that. If the thing is an ASCII valid character, and if it's not a valid ASCII character, then yeah, basically it will just show a dot to indicate that there's something there which can't be shown. Of course, it's kind of tricky in the case that you have an ASCII dot and you actually kind of want to see it, but I guess you'd know in that situation, or you're out of luck. Okay, so that's kind of the thing. The methodology that is kind of recommended, which I just think is kind of insane, I get in some ways where it's coming from, but I think it's ridiculous, would be to redirect this to a file, right? So I'll call this example.hex. And then you can open up whatever editor you want, Vim or Nano or whatever you want. You could open it up in a GUI editor too. And then, so... Oh, that's the wrong that's the wrong file. That is not how you want to edit a hex file. So then I can bring this in here, and maybe I want to change this beef thing here to cafe, which is a valid piece of hex, and then I save it. And then I want to get that back into the binary file. And well, XD has like the reverse operation, so it can take a hex file that's like, formatted in the way that it expects it to be. And you can say, take my example hex file and put it back into my example bin. And then if we were to run, just the hex dump again of example bin, we'd now see that our changes have been made. So they've actually been made in the binary file itself. So that's great. Except, yeah, obviously that's a terrible user experience, and just like, the annoyance of having to go out of one program into another and then do this conversion all yourself is kind of like, yeah, that's not what I really want to be doing. I want to be in one place. What I want is to have something that's like Nano, a command that I can run on I would want to run it on example bin, and then get basically this interface, make changes in here in a text way, right? And then when I go back into when I save it or something, then I want to see that reflected in the binary file immediately. Don't want any intermediate files, don't want to run multiple commands, just want one thing where I can do the edit. And obviously when I update stuff in here, I also want to see it reflected in the ASCII panel. And eventually I want to be able to insert and remove and do all these different kinds of operations. I'd like to be able to do things like highlight a line or highlight however many bytes I want to have, and copy and paste and be able to insert or replace. I want to be able to do all those things. So that's kind of the goal. So now that that is sort of clear and known, let's take a trip back to sort of the design goals. And I want to go for minimal design goals today because I want to keep this to a relatively short video. I want to be able to open, edit, and save binary files. I want to display in the kind of canonical format, which is more or less what you just saw. It's, I guess, slightly different in that really, I guess I want to show individual bytes separated out. And actually, eventually, I want that to be flexible, so you can modify how you view. Maybe you don't care about ASCII, get rid of it. Maybe you want to group things up in 32 bits rather than in bytes. And yeah, I want the flexibility, but for now, I want a pure byte editor view in what's called the canonical format. For now, just have a fixed editor size because I think that will make certain parts of it easier for now. But eventually, I want to have something that will scale with the size of your terminal so that you can edit in full screen if you want that, and you can bring it down to a smaller screen if you so desire. And maybe display a 32-bit interpretation of the sort of the 4-byte selection that you have, the 4-byte aligned selection. That's not a must-have, and if the time is getting on, then I might skip that. But I just want to like kind of begin to suggest that like this editor should do a little bit more. It should, like, the adding features like that is not actually going to be a that we should be able to fit it into the architecture. Okay, so the cool thing I want to do with this is I want to use something called Ink. Ink is a React renderer for the command line. So many people are familiar with React on the web. It's a really great way of kind of making declarative interfaces. It's a library that's got more complex over time, but fundamentally it's a really nice way to make a sort of reactive driven UI over time. And of course, it's been proven that React isn't only for the web because there are different renderers, right? There is the React Native renderer, which allows you to render natively on iOS and Android. And yeah, there are different React renderers out there that can do different things. And Ink is just one of the React renderers that allows you to go into the terminal and sort of declare an interface that way. So, you know, if you've used React, it's going to be kind of familiar. You know, you make a component and you can use like all the facilities of React, right? Because you still use React, right? It's still React there, like all the functions, and the renderer turns it into the final representation. So you get all the things like useState and all the hooks and all the things like that. And eventually, yeah, you call render, and that's your whole project, right? So you can see here, this is the example that it's rendering out. It's basically, you know, you run this and it keeps a counter, and it's basically incrementing this counter 100 millisecond interval, and then just rendering it out. And that's pretty much it. You can just display stuff like that, and it's really that beautiful, right? If you have, you know, this is kind of a feature of Node in general, but if your program just you know, renders out and then there's nothing left, there's no asynchronous kind of activity like taking input or running timeouts or promises which are in flight. If there's none of that stuff, then the program will actually just exit. And so that means that you can even render just a complex view of something using Ink, but it doesn't necessarily even have to be an interactive application. So that's also pretty cool, I think. Anyway, this is not going to be a React tutorial or anything like that. I'm going to assume you know something about React. And if you don't, this is not going to be the place to learn it. Probably wouldn't be the best teacher for it anyway. But yeah, so that's kind of the goal. what I've got here in this project is I've copy and pasted the example code, so we can work from that a little bit. I don't think we're going to need much of it. Got the example bin. I've got a file here called generate bin. I don't think we'll need to use it, but it's basically a tiny little script to just generate a binary file of a given byte size, so we can mess around with that if we need to. And I've kind of installed a couple of packages. I've installed React and its corresponding types. I'm going to do this in TypeScript. Yeah, I mean, pretty much for every project I do these days, I'm writing in TypeScript rather than JavaScript, because basically I get the JavaScript language with some type safety guarantees and some nice facilities there. So yeah, I kind of recommend you do the same, actually. Not a dig at excuse me. Not a dig at JavaScript at all. Love JavaScript, but I think the added type safety, it takes care of many of the problems. So there's that. Okay, so I've installed types, React. I've installed Ink, obviously, and just TypeScript and TS-Node. TS-Node is optional. That's just for ease of use while we're illustrating it. But yeah, in the ideal case, you'd actually just compile this down and run it with Node anyway. All right. Oh, and if it's not clear, I'm going to call this project Bewitched. Because, Bewitched, there's kind of a connotation with hex there, like hex is associated with witches. Bewitched is like a state of, being enchanted in some way by a witch. And it ends in ed, which, is like an editor. Sed also ends in ed because it's an editor, it's a stream editor. So, yeah, that's the idea. That's what I'm going to call it. All right, I just want to get straight into it. So, what do we want to do, right? I'm going to change this counter straight away. I'm just going to make it an app. I'm going to get rid of most of the stuff in here because we're not going to need that. Not going to need any green text for now. And let's just put a hello world message there. And then we are going to render our app. Okay, so now running ts-node source. If all goes well, yeah, we should get a hello world. Nothing special going on, but at least we know that we're running React code now. All right, so the next thing we're going to want to do is we're going to want to read the binary file that we have. So we're going to use effect for that because that's how you do effectful stuff. And reading a file, especially asynchronously, that's absolutely an effect, a side effect. So let's get ourselves a piece of state. And I'm going to refactor this probably very quickly, but for now I'm just going to get some state. It's going to be called buffer. It's going to be called buffer, and we're going to do SetState, and we're going to say it's going to be a uint8 array. That's what we use for the buffer, and it will begin as null. And I don't know if it beginning as null is actually, you know what? I think I'm just going to begin it as an empty array, an empty uint8 array. So this will just be a zero, a zero element array, an empty array. Okay, so then we can use effect to load this file. And I just want to load this file once at the beginning of sort of opening this program. And obviously later on in the future, like maybe you want to open a file later on, you want to save and open a new file or something. Not going for that now. All right, so what do we want to do? We're going to need the file system and the path. So let's get everything from file system, fs/promises. Also, just a tip, if you're using a certain version of Node from a certain sort of, I'm not exactly sure from which version this is, I think 14 onwards, maybe even lower than that, but you can use fs/promises to get like promise versions of all of the read file, write file, all the asynchronous things. Like, it's a nice tip if you don't know it. So we're going to want path in order to like normalize path stuff out. I would love for this to just work in multiple environments, in multiple systems. I'm basically going to build it for Linux now. I'm pretty sure that whatever I build would also work on OS X, but it would be nice if it worked for Windows. So I think anything that deals with paths and stuff like that should use the path library in order to normalize to the operating system. Okay, so how could we do this? Well, what we could do, one thing, is before we actually get into doing any rendering or anything like that, we could actually check that we've gotten a file name argument, because if we haven't been given a file argument, then there isn't much we can do. I'm not actually going to cover like inserting bytes and removing them. I think I'm only going to cover editing for now. And so it wouldn't really make sense to start from a blank file. So what I'm going to say is if process.argv.length is less than 3, and it's 3 because the first argument is going to be node, the second one is going to be the name of the file, like index.tsx, and eventually it will be something like bewitched. But if it's less than 3, that means that we didn't get this third argument, which should be the first argument we're actually looking for. So in this case, we're going to console log usage, and we'll say bewitched input file. And then we will exit the program with non-zero, just to illustrate that this did not close sort of successfully. Okay. So now, by the time we actually execute this now, we know that there is a file name there. So what I'm going to do is I'm just going to put it, the input file is going to be process.argv, and it's going to be the second, like, 2 index thing. So here we can actually just read the file, right? So we're going to do fs.readFile, and it's going to be the input file, and we're not going to pass anything more, right? I'm not going to pass that we should read UTF-8 or anything like that you're probably used to doing with read file, because I want to get a buffer out of this, right? I want to get already a binary representation. When that's loaded, we are going to take the resulting I'm going to call it file. We're going to take the resulting file, and we are going to call setBuffer, and that's going to be new uint8 array, and we're going to generate that array from the buffer object. So what is input file in this way? Input file is supposedly a string. Oh, here it's a buffer. Oh, from file, right? And then we should be using file.buffer, which gives us the underlying buffer, because I think file would be a node buffer. I think you can pass a node buffer into into a uint8 array constructor, but I'm not sure, so I won't do it for now. Okay, and I guess we could catch, but actually I'm just going to let like the operating system error message come through. Like it will just say basically you specified a file that doesn't exist. We'll clean that up later. So by this point we should have a buffer, and what I'm going to do, right, is I'm just going to log out the byte length of the buffer here, the byte length, and then we can make sure that it actually loaded. Excuse me, yeah, we didn't we didn't pass it a thing, so example.bin. Yeah, we got a 256 byte file, and I don't know if you saw, but there was a brief moment there where it showed 0. I think I saw that, or maybe I'm tricking myself, but there should have been a moment where there was a 0 length buffer involved. Okay, so now we've got the file open. I want to view the file. I want to have a view into that file. So let's do a before we do anything, let's make a new file. Just call it constants. You know what? I think I'm just going to call it utils for now, and I'm just going to throw a bunch of miscellaneous stuff in there, and later on I'll clean it up. So we're going to have a constant for the screen width. We'll say it's 80 characters, and we're going to have I guess it's maximum 80 characters, and the screen height is 24. That's standard terminal size. Even though I just want to make this abundantly clear, I think standard terminal size is sort of, at this point, just means nothing, and there's no good reason to like conform to 80 character widths or anything like that. The only reason I'm doing it now is because I know that I can fit like the number of bytes in that line that I want to do. But yeah, on a modern system with screens with thousands of horizontal pixels, there is just no good reason of having an 80 character, like designing for 80 characters anymore. I think it's dumb. I think it's dumb in Git. I think it's dumb when you have a code editor that says, with a linter that says your line's too long, it's more than 80 characters, even more than 100 characters. Those are ridiculous limits that make no sense in the modern world. Just up on my soapbox for a minute there, but yeah, that's what I believe. Okay, so the hex view is going to be slightly smaller than our screen size, right? Because I want to reserve, I don't know, let's say 3 lines at the bottom for like status information. Maybe telling us our current byte index, maybe showing the value as a 32-bit int in little endian or big endian. Yeah, so I want to have a bit of a thing. So the let's say I'm going to make it all configurable. I'm going to say the hex view width is going to just be, for now, it's just going to be the screen width, and the hex view height. Yeah, that's going to be the screen height -3, right? Reserving 3 rows. Okay, good enough for now. So now we can come in and build a component, which I'm going to call hex view, and that's going to take some parameters. So let's say hex view, or it's going to take props, right? We're talking about React here. So let's do this, and the props we're going to take into the hex view. Well, we're going to need the buffer. I mean, that's for sure. UNA array. I guess that's all we need for now, but we're going to need some more things, so I'll keep that there. And yeah, so let's think about what we want to do for a second. And while we're doing that, let's go back to the terminal and let's run xxd. Actually, let's run a different program. There's another program which dumps hex to the screen, and it's amazingly, it's called Hexdum. And that has a flag for the canonical format. Because this is more the view I want to have for now. So this is the canonical format. I think I'll probably put a colon here. But this is what we're looking at here. So it's the same thing. We've still got an offset, but now we've got like bytes separated out. You can see that here they're grouped into 64-bit sections, right? Because that's what most modern systems are. They're 64-bit systems. So we've got byte editing kind of grouped together by 64 bits. And just progressing down, and what we're seeing obviously is that we get 16 bytes per line, so this counts up in hex in increments of 16. We still get our ASCII display. This is pretty much what I'm going for. This is kind of what I would like that to be. So let's go back here and let's think about what we're going to need for that. So we're going to need a collection of lines. Yeah, what I'm going to do is I'm going to group up a collection of lines, and they're going to be React components, right? And a line is going to be made up of the offset view, the byte view, and then the ASCII view. And it's going to be those 3 things together, and then we're going to have a bunch of those as our lines. And then our final component will be rendering up a big group of those lines. So I'm going to make lines, which is going to be a react.component array. That. I don't think we need to get more specific than that. And at the end, what we'll do is we will return, and here we've already seen the text component from Inc, right? But Inc obviously is not HTML, right? So it doesn't have all the HTML elements like div and a and all of those kind of things that you're probably used to. What it has is much more like React Native. It's got a bunch of primitive things. It's got text, it's got a box, which is kind of a flex box. And it's got a few others. I don't remember exactly what they are because I think I've mainly only used text and box, right? Because most of the time on the command line, you're just putting text in places. But yeah, you can do some nice stuff with box. You can automatically draw borders and things like that. Probably not going to do any of that for now. But in the end, we'll return a box which will contain our lines, right? That's the idea. And our box, we want to tell it that the flex direction is going to be column, because we want them to go columnar. Alright, so now we need to build up those lines. So I'm going to use a for loop to populate this array. And what we're going to want to do is we're going to want to take, we're going to want to have this like variable, which I'm going to call offset. It's going to start at 0, although that's going to need to be configurable. It's going to start at 0, and then while offset is less than, and this is also going to have to change, but I'm going to do this for now. While it's less than the buffer.byte length, and yeah, I'm not pulling buffer out, so that makes sense. While it's less than the buffer.byte length, not buffer, increment I. Not I, it's called offset. Okay, and then so now we're dealing with one offset at a time. And let's make a utility function in the utils. Export const, I'm going to call it 2hex. And what we're going to do there is we're going to take in a number, so I'm going to call it n. And we're going to have like a length, like a padding length. I'm just going to call it L because I'm lazy. The automatic one, I mean, we should always provide this. Maybe we should just always provide it. The idea here is that we're going to get n into a hexadecimal string, and we're going to pad the start up until L, like so it's up until it has a length of L, and we're going to fill those with zeros. And then obviously if like for offset, I want to show, just like in the canonical format here, I want to show like you know, a 32-bit kind of offset. And yeah, for that, we're like, you know, if we only have one number here, we're going to want to pad this up to 8. We're always going to want to pad that up to 8. With these ones, we're going to want to pad them up to 2, right? Like if in this case where we have 3 here, you know, we wouldn't want to just show a single 3. We would want to pad it out. So that's what we're going to do with that function. It's a function I write so much now across all these different things, mostly for debugging. Okay, so first of all, we can make this offset component. I'm just going to call it offset component. That is just going to be a piece of text, and maybe we'll make it bold because we can. And inside, that's just going to be a call to 2hex with the offset padding up to 8. I think I'll put a colon on the ends there as well, and probably a space because we can. Then we're going to want to have the byte representation, and for the bytes, yeah, I mean, it's just going to be another text thing basically, but for reasons we'll go into very shortly, I'm going to make it a box component. So I'm going to call this bytes component, and we'll make this a box. And this is going to be a horizontal box, and horizontal boxes are the default. You know what? I'm actually going to make the bytes individually first before I make the component. So what we'll actually do here is let's make a variable called slice, which is going to take offset and slice it, not offset. It's going to take the buffer and slice it from the offset to the offset plus 16. And well, let's make 16 a const, which is bytes per line. I want to show 16 bytes per line for now because I know that will fit in our 80 column system. Obviously at some point we're going to want to derive these numbers in terms of each other, but going for the simplest thing here. So this is going to give us the 16 bytes, maybe less, right? It might not give us a full 16 bytes, but it's going to give us the number of bytes we need to fill a line if they're available. So what we can say is, well, this is still a uint8 array. And when you have a uint8 array and you were to do something like map, which if we want to take these numbers and turn them into React components, we want to use something like map, right? It's the easiest way. But if you use map on a uint8 array, you can only map to back into a uint8 array, right? And that makes sense, because with a normal array, you can also only map into a normal array. But we need a normal array because in order to give stuff to React, at least I think, in order to give things to React, well, you can't have your values be, you can't have a uint8 array of React components. It just doesn't make sense. So an easy way to convert that to a regular array is to just spread out the elements, which will internally go through its iterator and iterate out numbers. And then we spread them out into a regular array. So that's what we're doing there. We're just sort of copying that into a regular array. So now we can take our slice and we can map it. And what that's going to give us is it's going to give us a byte value and an index. And I don't think we need to do anything with the index right now. But what we can do is we can just return a text element. And the text element is going to need to have a key. The key, I think, well, maybe we will use I. I'm just going to make it the offset plus I, right? Because that's going to be unique within the context. Obviously, using the index as a key isn't really advised in React, but I think this is probably fine for what we're doing. And yeah, we just want to show that value, right? So we're just going to call toHex with byte, and we want to go to 2, and that is that. Also, we want to have a space after it. Yeah, let's say that. So then our bytes component. I hope you're following me at this point. I realize we're not quite there yet. Our bytes component is just going to be a box with our bytes in it. And then we're going to get to the ASCII. So let's call it the ASCII component. And to get to the ASCII component, well, it's just going to be a text. And all we really need to do is take our slice and map it. Map it again, and this time we get our byte. We don't really care about the index this time around because we don't need to do any key related stuff, so I'm just going to get a byte. And what we want to do here is we want to kind of get its ASCII representation if it exists. What we could do here, and what I think would be the fastest way, although for now it won't matter, but like in the future, maybe performance when we're rendering a bigger screen might be a thing, or if you're targeting an older machine or something. For now, what I'm going to do, in order to just make it easy for me to see if the byte that I'm dealing with is, if it's an ASCII renderable byte, well, the simplest thing is to make a regex. So I'm just going to make an ASCII regex, which is going to check, it's going to check if we've got something that's A to F, or 0 to 9, right? That's all it needs to do. That's not true. No, that's not true. It needs to be like any printable character. So this would not work. This is only going to work for hex characters. Okay, you know what? We will do it the slightly more tricky way. So maybe I'll try to spread this over a couple of lines. It always looks weird, this kind of JSXy stuff. There are easier ways of doing it, putting parentheses around and stuff. But okay, so what we're going to do is we are going to check if this is in the range of the ASCII range. And so our character code, so what the byte right now, oh, it's already a character code, right? It's a byte, right? We don't need to do that. If the byte is greater than or equal to 20, which is the beginning of the ASCII renderable range, right? If it's 20 or more, and the byte is less than 0x7e, 7f. I think 7e is the last renderable character. I think. Anyway, If it's in that range, then we will return string.fromCharCode byte. And if it's not, then we will return a single dot, because that's what we do in that situation. Okay, so now we've got all the components together. Now what we kind of want to do is to kind of render them together. You know what I might do as well? I might do this thing that they're doing in this other thing, which is to put a bar on each side of the ASCII representation. What we're going to want to do is we're going to want to push into our lines component, lines array, and whoop, and that's going to be a box again. And what we're going to have in there is a couple of different components, right? We're going to have our offset component. We're going to have our bytes component, and we're going to have our ASCII component. And it doesn't like something here. Argument of type element is not assignable to component. Okay, does this just need to be React element? Yep, I guess so. Okay, I think we've got it with that. So now what we can do is replace our text thing here with a hex view, and we need to pass the buffer into that. So the buffer equals buffer. Yeah, let's try that out. Oh, that's definitely not right. So what's going on here? It looks like I've printed the same thing a bunch of times. That's really funny. Okay, so why is it doing that? And it's doing that because we should be incrementing offset by bytes per line each time, I think. Let's view it in the in this view instead, because I think that would be a bit nicer. So ts node source. Yeah, got to provide an input file. See, that's paying off already. Yes, unique key prop, that's true. But we're looking more or less like looking good here, right? We don't have this 64-bit split, but I don't care about that for now. This is looking perfect. We have the view right now. So this is a huge amount of the work already done. We're already at the point that xxd dump is giving us, right? We could pipe that out to a new file. Let's just make sure these get keys. So when we push this in the key, let's make let's make the key the offset. I think that, you know, we're always going to be rendering a unique offset, so there's no way that could go wrong. All right, the next step. Well, obviously right now, as you can see, obviously the program exits, right? And let's just look at that without the error of the key. Yeah, good. The process just exits. And obviously we don't have any sort of notion of a selection. So we need to be like selecting a byte, right? If we're going to edit, we need a cursor basically. At this point, I'm going to, I realized I didn't use the path. I didn't actually use path when I went to open the file. So what I think I want to do is to say that the input file, let's just do that really quickly, is relative to this, no, it should be relative to your working directory. So your current working directory, and that's where you join the path from. Unless it's an absolute path, in which case that wouldn't really make any sense. But I don't know, maybe path join is smart enough for that. I actually don't know. Could try it. Could try to make an absolute path out of it and see what happens. Yeah, let's do that. Why not? This should be in home Francis repos LLJS bewitched example.bin. Yep, and then it tried to do that. So we need to do a bit more path magic. I'm going to leave that for now, right? Because I know that this will work for now. Okay, so let's get back to the cursor off the sidetrack. At this point, right, we're going to have the idea of a cursor, and we've got this idea of the buffer. And they're kind of linked together, right? The buffer, the cursor, yeah. There's going to be more things related there. Like, because the cursor can be thought of as the current selection, right? And I think what I want to do is I want to start to make a richer representation of the buffer. Since it's our core central data structure of an editor, I want to make a more rich data structure for that, which an object rather, that is going to allow us to interact with it in a richer way. So what I think I'm going to do is I'm going to make a hook called useBuffer. Sounds about right. Yeah, so how's that going to work? Well, what we can do is export const useBuffer. Internally, I've gotten rid of it on my selection. Okay, it's fine. Buffer, set buffer, use state, and unit8 array. So we've got this, and then kind of you can imagine that in the end we return like a buffer, and maybe we return set buffer, although I don't think we're going to need to do that explicitly. So we're going to have this, and we're going to have our what do we call this? I think I'm going to call it the cursor. Let's call it cursor, and set cursor. And I think with the cursor, we're gonna want to have some some more not only just setting it arbitrarily, but also some richer operations like move left, right, up, down, that kind of stuff. So we'll have it be a state, and we'll have it start out at 0, and we'll just return all of this stuff for now. Cursor and set cursor. It's just grouping up a bunch of things for us. Let's replace this here with buffer, set buffer. This would be easier if I already said that this was use buffer. So set buffer, cursor, and set cursor. Okay, and then I want to pass the cursor to the hex view. So let's do that. Cursor equals cursor, which means we need to say that we take a cursor here, which will be a number. And yeah, so what we're going to do is we're going to render this differently. We're going to want to say that, like, for the byte that we're dealing with, when we come to render the bytes, like, if that byte offset plus I is equal to the cursor, then we want to kind of show it in some way, right? So what I think we're going to do is we can just check that, right? If offset plus I is equal to cursor, which we haven't pulled out here. If it's equal to cursor, then great. Then we basically want to do this, but actually, for reasons I'll get to in a second, we're going to want to put this in a box because we need to render 2 text components here. It also means we need to put the key on the box rather than on the text component. And we still want to render this, but what I want to do now is I want to say that it's got a different background color. So the background color is going to be white, and the foreground color is going to be black, right? We're going to invert the, wait, that's wrong, right? No, that's right. And then the reason I'm going to have a second text element is because I think that we're going to get a different background color with a space, and I don't want that. So I want to have a separate space there. And now, yeah, okay. It's getting a bit hard to read. I'm grouping this code up in a horrible way. But that should do it. So if we go back and render this now, what I would think we would see is the first byte selected. Perfect. All right. Now we need to be able to move that selection around, right? That's the next logical thing. For that, I'm actually going to make another hook. So I guess I'll copy that. I'm going to call it use movement. Use movement. Use movement. And what I'm going to want to have in there is that we take in movement props. And now it's not. Now they're not props, right? These are now params. I don't know. Doesn't matter. We're going to want to take in the cursor. We're going to want to have set cursor. For now, right? In the future, I want this to be. Yeah, and this now we get to this thing, which I'm pretty sure in React there isn't a nice type for this already. So I'm just going to make a type for something called a SetState function of t, which is basically a function that takes something which is a t and returns a void. It doesn't matter so much, but that is the shape of a SetState function, right? If I have set buffer, I would need this t to be a uint8 array, and then it's going to return nothing, right? That is the signature. I don't think React exposes that, as far as I know. So this is a SetState function where number is involved. Put that in. Cursor, set cursor. Yeah, that should be enough. So what we're going to do here is basically, well, two things. One, we're going to use something that we get from inc. So inc gives us some hooks, and one of them that it gives to us is use input, right? Which is of course necessary and nice and usable, because like when input comes in from the keyboard, you know, you don't want to like handling that in the command line is going to involve us, like if we did that ourselves, excuse me, that is going to involve us essentially having to set the terminal into raw mode and all of these other things, and who knows if that's applicable to different operating systems. And with this now we can use input, and then we're going to get something that's going to give us something called an input and something called a key. And basically input is going to be a string, which just represents like the thing we pressed, right? Anything that we could render from the keyboard, like a % or a hash or something like that. And key is going to give us more rich information, like was it an arrow key or something like that. So that's pretty handy actually. Now, one useful thing that I think we might do here is to also take the buffer. I'm going to take the whole buffer, but really we only need the byte length. Refactor it later, like I say. So if, like what we're going to do, right, is we're going to say like if the key was, what's this, like left arrow, then what we want to do is return, I think we can just return stuff from in here. We want to return set cursor. Absolutely not. I guess, yeah, I didn't take any of these things in. So let's go to movement params. So we're going to want to take in the cursor, set cursor, and the buffer. So we're going to want to take set cursor, And what we're going to want to set it to is the current cursor, -1. Now, you can imagine how that could go wrong pretty quickly. So we can use math.max between that and 0, right? So whatever is the bigger number of these two things, we'll set it to that. So basically, if we were already at 0 and we went back 1, there's going to be -1. We're going to take the bigger thing, which is 0. That's going to prevent us from going off the edge of the buffer, which is really useful. If we have a right arrow, we're going to do pretty much the same thing, except we're going to want to take the minimum value between the cursor +1 and the buffer byte length. Right, because we don't want to go, I guess we want to do it -1, right? Because you can't set your index to the byte length of the buffer. That's going to prevent us going off the other side of the buffer. So that's pretty nice. And what I also want to do is, for example, to have down arrow. And if we go down, what we actually want to do is we want to decrease by bytes per line. Yeah, that's pretty much it. We want to decrease by bytes per line. And if it's the up arrow, we want to increase by bytes per line. And we'll again byte length -1. Yeah, so like basically this is going to allow us to do some navigation around, right? And there are some circumstances where we're probably going to want to turn this on and off, but yeah, use movement, that should work for us. In fact, actually, I'm going to add an enabled property, which will be a boolean. And I know that we can just turn the use input on and off, right? It's got what is its option? Options, and I can't get to options. I think it's is active. Yeah. I'm not going to call it is active. I'm going to call it enabled because that's how I would think about it. Yeah. Okay. So let's try that now. Let's actually go to the main TSX, and we'll do it here. We'll say use movement. And we're going to pass it some stuff. What we're going to pass it? We're going to pass it the buffer. We're going to pass it cursor. We're going to pass it set cursor. And for now, we'll just say enable this true. All right, let's try that out. Let's clear first. Clear it. Okay, the program didn't exit, and yeah, something's wrong because when I press down, I'm getting set back to the beginning, and when I press up, I'm actually going down. But it seems to work, so we just need to fix the up and down. If I do Control-C, it does actually exit, so that's nice. Let's have a look, because we should just be able to swap down and up. So that's up arrow, down arrow. Yeah, right, because when we're going down, we're adding, and when we're going up, we're taking away. One more time, just to make sure. Excellent. That's great. So that is like a huge amount of the interactivity already there. Now we need edit capability, right? And the way I want to do the edit, let's just go back to this screen to take a look. The way I want to do the edit is that, say I'm selecting this byte here, B8. If I press any character in the range A to F, 0 to 9, I want to edit the first nibble, actually the most significant nibble. So I want to edit that 8, right? Because that's how we work as humans. Well, no, that's not true. That's how we work in the West as humans. We work from left to right. Obviously, if you're from a country that has right to left, then this is not necessarily like as naturally intuitive as I was about to claim it is. But but at least I think technologically the world has been conditioned into working like from left to right in this way. I could be totally wrong about that, and I'm sorry if I am. But yeah, I'm gonna make it so that when you press a digit or a hex digit, you're gonna first edit that most significant nibble, and then the second time you press something, you're going to edit the next one. And if we get really fancy, I might even just increment the cursor after that as well. But we'll get to that. Yeah, that'll be about it. If we happen to like move around during that time, like move left, move right, I think what I'll say is that we'll kind of reset that. So if you go back left, you don't want to be editing the least significant nibble all of a sudden. So let's see if we can do that. And what I'm going to do is I'm going to make a completely different hook, which I guess I'm just going to call it use byte edit. I want as much as possible to have these completely separated out. So let's say use byte edit, and this is going to be byte edit params. Now you can imagine that since we're going to write the buffer, we're going to need set buffer. So that's going to be not set cursor, but set buffer, and the SetState function is going to deal with uint8 arrays. We're still going to need the cursor. We're not going to need set cursor, although actually, you know what? I'm not going to do the fancy thing with moving it forward at the moment, because I think I want to get a bit more sophisticated with modeling the movement. I want to move this stuff, like the logic of moving left, right, up, down. I want to move that out into the use buffer and expose that via high level interface. So let's do set buffer instead. And so what we're going to do here is now we're going to need a regex that is like the one I was thinking I would write. So what's this going to be? This is going to be a hex regex, and super simple. It's going to capture when we use 0 to 9, A to F. That's it. That's all it's going to do. Let's even make it a function. Is hex char. And what we'll do is we'll take a character, which will be a string, and we're just going to say, does it match this regex? This isn't really efficient because we recreate the regex every time. So yeah, I won't do it then. I will do hex regex. You shouldn't be thinking too much about efficiency ahead of time, although like I guess you shouldn't be too pessimistic as well and just like writing the code stupidly to begin with if you know that it's like one thing. So okay, so that's how we've got it. And what we're going to do now is we're going to use more like that input parameter that we got, and we're probably not going to use the key. And so what do we want to do? If is hex character the input, then we want to make some edits. But we need to keep track of if we're on the most significant or the least significant nibble, right? So let's do some set state, and let's say is ms, no, let's do is most sig. Am I going to write this out? I'm just going to call it MSN, and then set is MSN. Use state. And it will be true to begin with. And we need to bring in use state from React. So if it is, then we need to figure out, are we editing? If we're editing the most significant nibble, well, what's our value? Our value is going to be, like, our numerical value is going to be the input. It's like the input cast to a number. So that's it. That's all it is. So what we want to do, right, is think about, we're going to say that our buffer under the cursor is going to equal, like, whatever it is now, right? We want to keep the original value, but since we're editing the most significant bit, like, we actually want to zero out the most significant part and keep the bottom part, and we can do that by ANDing with OF. And then to put something in the most significant position, well, what we want to do is take value, which is a nibble, and we want to shift it up by 4 bits so it becomes the most significant part. Excuse me. This is today the most low-level stuff we're going to be doing. So that's that. And kind of in the opposite case, well, in the opposite case, we want to preserve the other way around, right? We want to get rid of the bottom part. And just to keep this like in the same place, yeah, we're just going to do this basically, right? That's already the low nibble. We're keeping the high nibble and we're ORing them together. All right. And in both of these cases, we're going to want to set is the most significant nibble to the inverse of whatever it is now, right? Because we're done. And yeah, so if it's a hex character, we're going to do that. And I guess, and what I might do here is just put an early return there. And now kind of the other thing that we could do is we could say, well, if it's not, if it's like, let's even do it like this. Let's say key. And yeah, I think we'll just do it like this, right? If key dot left arrow or key dot right arrow or key dot up arrow or key dot down arrow, if it's any of those, which means we're doing movement, then let's just set is the most significant bit nibble to true. I'm not sure how I feel about doing like this because we said that we were separating out movement and bytes, but somehow we're bringing it back together. But I think this will actually make this work nicely for now. Let's bring this this one in. So let's say use byte edit. And for that, we need not set cursor, but rather set buffer. And let's go try that out. Let's see how that works out. All right, so it's running. I can move around. Let's see if we can change this to 0, 0. So press 0, I change the most significant nibble. Press 0 again, and I've zeroed it out. And that's nice. FF. Oh no, FF did not work. Oh, that's interesting. AA, 1, 1, 2, 3, 3. Oh, I know what I'm doing wrong here. This is the one time. This is really, see, I'm kind of, when it comes to turning numbers into, turning strings into numbers, most of the time what I would advise is to actually just use the number function. But we can't do that in this case. In this case, we need to use something called parseInt, which is the thing I would usually not advise to use. And we need to say we're using base 16 because this is a hexadecimal number, right? So in order to parse a 16-bit number, we need to do that. So let's try that again. All right, so now, oh, that was my fault. I pressed that too early. FF, cool, FE, EF, and then let's do A. Then I'm going to move to the byte 1 back. And then if we were to edit now, right, if we hadn't put that movement code in, then we would actually overwrite the E part of this FE. But if I do 8, then we write the most significant nibble. So that's excellent. That all works perfectly. The last thing that I would like to cover now is the ability to save. Like the ability to go in and make an edit and then write it back to the binary file. And I want this to be much more advanced in the future. I want the ability to basically pop up some sort of secondary view that's going to say like, hey, choose a path to save this in. Maybe even show a file, maybe even show like a file menu or something like that. But for now, what I'm going to do is just say that if you press save, if you press S, let's say, if you press S, then it's going to yeah, let's just have it save the buffer straight away. I want it to have maybe a confirmation and then we could build a confirmation, but I feel like I'm already making this video longer than I want it to be. This is only the essence of the thing, and I hope that what you're going to take away from this is like, one, an appreciation of the beauty of this library Inc. I really think it's a great library. I want to shout out the developer here, and I'm probably going to mispronounce his name, but Vadim Demadis. I hope I've said your name right there. You've made a really awesome library. I think it's really cool. yeah, so I think what I'm going to do is just have save as be the S, basically have no feedback from it, and then I'm going to continue working on this library. So I'm going to leave a link in the description to the GitHub, and you can go through, you can take a look at the commits that I'm going to make, and you'll see how I'm building up the functionality over time. What I'm realizing actually is that we are modifying the buffer, but we are not actually calling setBuffer, and yet we're still seeing the results propagate. And that's something I wasn't really sure if that was going to work or not, but apparently it is, and that's great. And I think the reason that it is because every time we actually do that, every time we end up modifying the buffer, we're calling some other form of setState. So in this case, we're flipping this, which is going to cause a re-render, right? Because this piece of state belongs to like the root component, and therefore we would need to re-render. So that works just by coincidence. And you know what? I'm okay with it because in this case, we don't want to be creating new buffers each time. Like React would say to us, you should be immutable. You should be returning a new version of the object every time you push it in. But in this case, I don't want to do that. I don't want to create new buffers each time because that's going to get expensive in the future. Yeah, so I have to implement the save. I haven't done that yet. So let's do one more hook. At this point, we'll call it use save. Super simple. Do we even need parameters? I don't think we do, other than enabled. So let's have, you know what? Let's have save parameters. And let's just take enabled. So we'll get rid of all of these parts. We're going to use input, and the only thing we're going to look at is the input. We're not going to, actually we're going to need more than this, of course, right? We're going to need, we are going to need the buffer, and which is going to be a uint8 array. And I think maybe that's it. We're probably going to need the output file name, which will be a string. Okay, and if we've got those, we can get the buffer, we can get the output file name. Yeah, this is not the way I would do this in the future, but just for now, if input is S, in that case, we're going to save the file. So how can we do that? We're going to obviously need the file system again. So let's say star as file system from fs promises. And we don't need path because I'm going to assume that by this time we've been given a full path. And then in that case, I shouldn't call it file name. I should call it output file path. And it's going to do this thing. Yep. So if we get that, and I'm pretty sure that use input is just like any kind of event handler that you would have in React where you're allowed to do side effects. So I'm going to do side effect stuff here. I'm going to write a file. I'm going to write the path, which is output file path, and the data is just the buffer. That's it. That's our save implementation. So back in the index, we can bring it in. Whoop. Use save. I guess I didn't rename it. Use save. Use save. Don't need cursor, don't need set buffer. Do need the output file path. And the output file path, well, usefully for us, is just the input file. Again, you know, that's obviously horrible. You want some sort of confirmation as a user. Realizing that we also didn't show any feedback information like the byte stuff. Maybe I'll do another video on this, or maybe I'll just keep developing it. But I think at this point, you've probably gotten a really good idea about how this thing kind of works and operates. And kind of you can probably see the way forward in how you would actually go further from this. So let's open example.bin again. Seems to work. What I'm going to do, right, is I'm just going to set the first 4 bytes to 0. I guess the first 5 bytes to 0. going to press S. No idea whether that works or not. I'm just going to close it, clear it, and then let's use something like Hexdum to verify what went on. And I used lowercase c there, and it should have been this c. And as you can see, we actually did modify the first 5 bytes. So at this point, we've written a functioning hex editor. It is the most minimal hex editor you can imagine. It doesn't have any of the things that I think are also really important, which is also like windowing. So when I talk about windowing, I mean, let's say we had a much larger file, and we wouldn't want to, like, we want to be within the bounds that we've defined as the program, right? We want to say that, hey, this thing is 80 by 24 characters, and I don't want to show a window that's bigger than that. Yeah, so in that case, we'd want to like kind of not start at 0 here, but rather start maybe, you know, down here at 80 and show a whole screen's worth of stuff from 80, and then to be able to go up and down in that view. But yeah, these are all just going to be like little advancements on this thing. So I hope you found that interesting. By the time you see this, there may be a first version of Bewitched published, if only for the fact that I don't want someone else to swoop in and take the name now. And of course, yeah, you'll find stuff in the description about this. Thank you for watching. Thank you to all the patrons of this channel, and I'll see you next time.